So we'll go ahead and get started in like a minute. Okay, so I'm going to continue where we left off with the skill tree system that we started yesterday. I wanted to do a quick overview of where we're at, where we landed, and then talk about what I want to work on today. So yesterday I walked through the post that was on Reddit that someone asked how you would do this, and I kind of explained in the comment how I would do it, and then someone said they'd like to see it visibly. So I put this together to talk through the design. First thing being that we want it to be data driven, so we're going to use primary data assets. You could use a data table if you'd like, but I like using primary data assets to leverage the asset manager. So we built this large asset that you see here with some UI elements for the display name, its icon, description, parent skills, so that we can actually tie it together in the UI later. We have skill requirements, which is a custom U object that we created that allows us to create all sorts of different item types, or requirement types, excuse me. And one of the ones that we want to create today is going to be the gameplay tags one. We already did the level one and we looked a little bit at the required skills, but we want to now take a look at the requirements. Last but not least, we had skill ranks, which was a custom structure that we called F skill rank data, which actually has all the abilities and effects to grant and apply, and as well as a cost. And so if we take a look at that here in a moment, I'll show you what that output ended up being for that data asset. Just some more examples of what I was trying to accomplish. Basically, as I thought through a design, I wanted to have some examples of abilities or skills that could be used, and then design around some of those limitations or requirements actually. So the first one we have is improved wisdom. It just gives us applies a gameplay effect and it boosts our mana. Super simple. Then we have another one that grants us an ability and it requires the parent. We have the second one over here, which I call toughness, which is applies a gameplay effect, but it applies it multiple times. It's additive and has a rank associated with it. So we'll have to explore how that works. And then the last one I wanted to require 2 different parents as a level requirement, which plays into our skills requirement, and we might add some sort of like class requirement, a mage, a gameplay tag requirement, but it also gives an ability and applies a gameplay effect. So this kind of culminates with everything that we'd want to do, and then we'll have some more simple ones above to get us started. So this is what we designed yesterday. I do want to add the required gameplay tags requirement class U object, just to have that ready to go. And then we have we want to work on the actor component and then the skill state today. So if I go into Unreal Engine, let's take a look. This is the improved wisdom skill that we created. It's divided into 3 sections in our U object, or excuse me, in our data asset. The first is our UI, which has a display name, a description icon, and then a parent skill IDs list. In this case, it's our first one, so there's no parent skills. Below we have requirements, so we have these are the requirements for this one. I gave it a level requirement of level 1 and a skill requirement just to test this out, where we can actually select the skill that we want. So in this case, for this first one, we don't have any requirements for it. It's just going to be available, so we'll go ahead and delete those. And then ranks, every skill is going to have 1 rank. This is the base rank, so rank 0. This is what the skill just applies. So in this case, we're applying add wisdom gameplay effect, and that adds a certain amount of wisdom. I think we put it at 5%, and there's no abilities. So this is our current structure. Like I said, I wanted to go ahead and add the gameplay tags, required gameplay tags requirement. So let's go into Writer and talk through how to do that. So we created close some of this up. Perfect. So we created a custom U object called U character skills requirements base, and this is a abstract class, meaning we cannot actually create a concrete version of this. We have to implement it some other way, and we implement it by creating our level character skill requirement and our skill character skill requirement. And so now we're going to make one that has gameplay tags. Hello. Thanks for joining. So this is the base class that we're working with. So we want to go ahead and create a new one here. So I'm going to go into our character skills. We're going to go to our requirements, add a new Unreal Engine class. Oh, I'm in the wrong folder actually. I'm going to do this in our public folder. New Unreal Engine class. This is going to be our character skill requirement base. And this is going to be a gameplay tag skill requirement. This might be too... Oh, perfect. Okay, gameplay tag character skill requirement. Kind of long, but it explains what it is. So again, if I close this up and we go to our level, you can see the things that we need to do. We want to have a U property here. Why is it doing that? Sorry. Okay. And we want to call this tags, and we're going to make a T array of F gameplay tags. So in my comment on Reddit, I wrote that it's oh, we could just do it. That's what we'll do. We're gonna do a F gameplay tag container. We don't need to create an actual one for this. Required tags. So in my comment on Reddit, I said that you needed to have required tags, or to use gameplay tags, and it's often super recommended to use gameplay tags. It's a pretty powerful tagging system. When you get into gameplay ability system or GAS, you're going to want to use gameplay tags a lot. So if they're not enabled, if you go into your build.cs file, you can just go ahead and add gameplay tags in this array. You can see I have a bunch in here. I have a paper 2D, paper ZD, the UMG, and some developer settings stuff. Lots in here, but basically, if you're going to be using GAS and gameplay ability system, you need gameplay tags and gameplay abilities. Definitely start leveraging gameplay tags if you're not. They're very powerful in Unreal. Okay, so we have our required tags, and now we need to implement these virtual functions. So I'm going to grab them, copy them from my level requirements, and now I'm going to hit Alt Enter to implement them or create a definition. And now we need to think through how we're going to handle does meet our requirements. So we'll say true for now. And for our text, we'll just says requires. We'll do requires a number of gameplay tags. Requires 10 gameplay tags. And I think I can do and we'll do required tags.num. I think this needs to be in a text. I did this in another one. Let me pull it up. Here we go. Oh, I used the wrong format. Here we go. And we'll cut that and we'll paste that there. There we go. All right, perfect. So I just want to have a statement out here that says what we want to print. So requires this number of gameplay tags. All right, but we need to think through how we actually get our player tags. Well, in my case, for the gameplay ability system, or yeah, gas, I'm putting all my tags onto the ability system component, so it's a common component that I can pass around. So similarly that we did here in our level character skills requirement, I'm going to grab the same information. So I'm going to come in here, copy it and paste it in. Now we need to add all the include statements because I don't have all these. So we'll get our structured log over here. We'll grab our both of these as well. That should give us access to our pawn, our logging, and our ability system component. So now that we have this, the ability system component has a loose gameplay tags container. And you can see loose gameplay tags. So I think we can do a get loose. Let's see. We want to get them though. Here we go. So we can get gameplay tags. This is going to return a gameplay tag container. And we can then say with this gameplay tags, it's going to return it. We can compare does tag container match, and we can see that this takes in an other container. So I think we can pass in our required tags. What is we want E gameplay match type. Let's go to this. Oh, it's deprecated as all. All right, there we go. Perfect. I thought it was more simple than this. So we can put this in an if statement. Honestly, we can just return this. So basically what we're doing is we're going to have a container of tags called required tags. And if we have all these tags, so if we have all the tags in required tags that are attached to our ability system component, then we can actually apply, or the skill would be like kind of unlocked. All right, let me redo this. And then we'll do a quick overview of what we did. Hey everybody, thanks for joining. Working on a skill system that I started yesterday based on a Reddit thread where someone asked about how to do it. So we're working on a gameplay tag character skill requirement right now, where all of our skills have a set of requirements. In this case, we have 3 different types of requirements a skill can have. We created a gameplay tag requirement. We created another skill requirement where you have to have another skill. And then we've also created a requirement where you need a certain character level. And we built that using this custom UObject class. So I just implemented the gameplay tag one, where in does meet skill requirements. We're going to get from our player controller, we're going to get the pawn that we want. We'll check to see if the pawn's valid. And let me call this gameplay tag. And then we then attempt to get the ability system component from that pawn. If it doesn't exist, we're going to return false and throw an error. If we do have it, then we're going to do a has all comparison to all the gameplay tags that are owned by this ability system controller. If that returns true, then we meet the requirements. If it doesn't, then we don't. So now that we're back in the editor, I can show you how this works. So if you have a class requirement, a specific class requirement, we can, in our requirements array, we can add one, and we can say maybe this ability or this skill is only available to a certain class. And in my case, all my classes are actual tags. Oh, I haven't implemented that in here, but we could. So we could have a, I did. So basically we can implement a, we'll just do it now. So let's manage these. We're going to call it character.classes.mage. So in here, we want our character classes and we want our mage class. So basically this is now saying that this skill requires this player to have the mage class tag, which is a gameplay tag. And the mage class tag just tells the player or the ability system controller that this person, this character, this player is a mage. So there we go. So now we've added the, if we go back to our design, we've added gameplay tags requirements, the character level requirement, and then required skills requirement. So now we can then talk about state and our skill actor component. So let's go back into our editor. I'm going to close out of some of these so we don't need them anymore. And inside our character skills folder under public, I'm going to right click. We're going to add a new Unreal Engine class. It's going to be actor component, and we're going to call this character skills component. And I'm going to put this in a folder called core. All right, so this is just a base U actor component, right? So we can attach this to any actor. So in this case, I'm going to put it on my player, but we could put this on any character. So like, even if you wanted to implement this on your enemies or your NPCs, you could do that. And the skills and as long as your NPCs and stuff have the ability system component, then everything will be implemented correctly. It should still work because nothing so far has been player specific, right? We're passing in just generic controllers and things. Okay, so now that we have this, we said there's a few functions we wanted, but really we wanted this active skills map, which is a map that has a key of a primary ID and then a skill state. So I wanted to work on that because it also requires us to build a structure, which we'll implement. So I'm going to move a couple things around. And we'll do this. So the first thing that we want to have here is going to be a U property, visible anywhere so we can see it. Blueprint read only. We don't need this meta. And this is going to be a T map. And it's going to be a primary asset ID. And then we need to build our state. So I'm just do F string for right now. And this is going to be active character skills. So let's go ahead and make this structure now. So we said we wanted a skill state, right? Skill state keeps track of the state of our skills. Pretty simple. So like we have a data implementation. What is the data required to create a skill? And as soon as we activate it, we're actually going to create an implementation of this skill. And we're going to do that and monitor that through a state class. And we're just going to make that a structure for now. So in my structures folder, right click, add new struct. We're going to call this character skill state. This might be better off inside a U object, but we'll leave it for now. So now we're going to do U struct, and we'll delete that. F paste. We'll make this a blueprint type so we can access it in blueprints. This works. Actually, we want this to be blueprint read and write. All right, perfect. So the first thing that we want here is a current skill rank. So this is going to be int 32 current skill rank. This will be set at 1. We'll copy this, and now we want to add our 2 arrays. So active skill effects, this is going to be an effect handle, and then skill abilities is going to be a gameplay ability handle. So we're going to make a T array. Let's call this active character skill gameplay effect. That's a lot. We'll just say active gameplay effects. And then let me copy this, and we're gonna do a similar one of active gameplay abilities. And I'm actually gonna be more verbose and say handles. So we know that these are the handles for each of these things. So for our abilities, we want to say gameplay. I think it's a U game. Oh no, it's an F. It's a struct. F gameplay ability handle. Is it a spec handle? I think it's a spec handle. So handle is like a key to our gameplay ability. So we should be able to pass in to our gameplay ability a spec handle, which will give us the active gameplay ability. So it's good to store which ones are activated by this character skill. So now we want to do the same thing for effects. So we're going to do F gameplay effect spec handle. Same thing. And now for every active skill, we can know what rank we're at with it. And we know what's activated, the effects and the abilities, right? These are the two things that actually get applied. And we will know the primary data asset ID, which is important so we can get access to all this data because it's stored in a map that allows us, that has a primary asset ID as its key. So instead of this F string, I'm back in the actor component. Instead of this F string, we're going to say F character skill state. And this is going to be active character skills. Perfect. I don't think we need our tick component, so I'm going to delete that. And honestly, we can keep our begin play inside public. Fine. Let's delete this for now. What I'm going to do, I think, is no. Just trying to think how I want to get this started. We're going to create a new function. And this is going to be blueprint callable. And this is going to be a void. No, we're going to do a bool try unlock skill. I'm trying to think. We're going to want an F primary asset ID. And we're going to say skill ID, asset ID. And we will implement this. So I haven't implemented the S. I haven't thought through the implementation of this unlock skill yet. So I'm kind of trying to think through as I type it out and talk to you all about how I'd want to do this. As well as clean up this component file. So like we don't need tick, so we can just have that as false. But what I'm thinking about try on unlock skill is when we try to unlock a skill, that means we're trying to activate what's we're trying to activate its effects and its abilities. And there's a bunch of things we need to do. So the first thing that we need to do, as I'm thinking through this, is we need to load the asset based on asset ID. We need to check if we have requirements, if we meet requirements, check to see if we have this applied already. Do we already have this skill? We don't want to unlock it again. Check to see if we have requirements. Honestly, this goes before we should be the first thing we do. So do we have the skill? No? Great. Let's go ahead and load it. And then we can check to see if we have met the requirements for it. Do we meet the requirements? Then if we meet the requirements, we want to apply effects, apply abilities, or grant. And then return true. If any of these fail, we're going to return false. So we can implement this last one, return true. That's our ideal state, right? Where we've actually unlocked it, we've applied it and added it to the map. Do active skills. So we need to actually create the state. I missed that one too. Which we'll probably do before some of these steps. So something like this. All right, so the first thing that we want to do is that we want to check to see if we already have this asset ID. And we can do that because our active map contains a whole bunch of keys. So we can do our active skills map. And we can say find key. I think this returns. I don't remember. Let's see. Really? Contains. All right. If we contain the skill asset ID, we're going to say if. So if we already contain, we're going to return false. And we can do a UE log FMT. Or we do a log temp. Warning, maybe? I don't think it's necessary an error. And we can just say active character skills map contains already contains skill not unlocked, something like that. So basically we're just telling ourselves, hey, we've tried, we already have, we contain the key, we don't want to try to do another one. All right, so then the next thing we want to do, if we don't contain the key, that means we want to load it and then try to unlock it. I think we want to do U asset manager. We'll call this asset manager is going to be equal to U asset manager get. What is the function? Let me do this in my, there's a subsystem I have that already has this done. I think it's this looting one. I don't remember all the loading logic all the time. Knights and characters and spawning. I know I have it somewhere. What, it's a get. Definitely thought it was like get asset manager. Oh, this is so silly. Oh, you know what? Nah. Why did I do that? Mm-mm. Mm-hmm. Sorry. I know I have this somewhere. I don't. Trying to think. So, what would use it? I have progression. I don't think the leveling component does it. No. I thought my looting subsystem handled this. Clearly didn't though. Okay. Okay. One day we'll find it. I cannot believe it's not in that one. Is it in? I only thought it'd be in spawning then. This is a problem. Here we go. It's literally just get. Frustrating. Okay. I knew I've written this code somewhere and I was just forgetting about it, and I didn't want to where are we at? I didn't remember where I had done it, so here we go. All right. So const asset manager, and it's literally just get. Great. And it's a reference. Cool. All right, so now we want to load the object, and we can load this here with this if statement. So if we have it, so we'll say if, good to practice typing it so I can remember it better. U object pointer loaded asset is going to be equal to our asset manager dot get primary asset object. Now this, and we'll call this our skill asset ID. So the thing here is get primary asset object is a synchronous operation. So it's going to load it synchronously. If we want to do asynchronous loading, which we might want to do in the future, we'll have to create a function in here to do that. But for now, this works. So maybe we'll even make it a comment. It's like optimization to do optimize with async loading. I just think that adds some complexity that's not needed right now, so I think we can kind of ignore it. So we're going to say u character skill asset. We want to cast to this, and we're going to do that. So if the cast is complete, we can do something. If the cast fails, then we want to do something. So what do we say? So if the cast is good, so I actually want to do this. Oh, bummer. I was going to do some early returns, but it's fine. So if it's successful, we've cast it to our asset. We now want to check to see if we've met the requirements. So for each asset dot skill requirements, which is our U character skill requirement pointer. So I think we could probably say const U character requirement if requirement dot does meet skill requirement, we're going to break. Honestly, I think we can just return false here. And it doesn't like this because we need to pass in a controller. Why doesn't it like requirement? Oh, it's because it's const. Not convert this argument type. Yeah, that's what I thought. Okay. So we're going to loop through all of our requirements. And if our requirement is met, or if it's not met, we're going to just return false. So as soon as we don't meet a requirement, we're going to return false. So that satisfies this. Now we want to create a state object. Now I will say I don't totally like having everything buried in these if statements. So I think we should clean this up before we get too deep. It's gonna be way too hard to read. So I'm gonna say if the loaded assets is bad. I think these early returns are a lot easier to read. So we'll say fail to load primary, let's call it character skill asset based on given asset ID. Cannot unlock skill. So what I'm doing here is I'm kind of preemptively optimizing, but basically I'm seeing that we're going to have a lot of if statements and for loops embedded, and it becomes a lot more difficult to read. And I want to stop that, because one of the good things about coding, and something like when you're working on a big team or like a game company, whatever, is you want readability. Some of these optimizations and things, or trying to use minimal lines, doesn't help if you can't read the code. So like this is pretty explicit. We're loading the object. Did the object load? Yes or no? Okay, if it did load, great. We're going to go to the next step. So the next step here is we want to cast. If our cast fails, then we want to return early, so we don't have to do everything. I like this pattern because it gets us in a place where I can quickly see what's happening. We're just doing some initial checks. Hey, did this work? Yes. Did this work? Yes. Did this work? Yes. No, no, no. Then we fail out and go somewhere else. So here we're at. We loaded the asset, and now we want to cast it to our skills asset. And I'm actually going to label this our character skills asset to be a little bit more specific. So if it failed to cast, we'll say fail to cast loaded asset to character skill asset based on given ID. Cannot unlock the skill. Perfect. Okay. These could be errors, actually, now that I'm thinking about it. This one's not. I think this is an error, though. This is that, hey, it's already happened. It's not a big deal. We'd like to see it, but it's not an issue. As much as these two things are real failures. Okay, so now what we want to do is check to see if we meet requirements. So if we're going to loop through all of our requirements like we're doing here, and we're going to call that function that we created does meet skill requirement. If it does not meet, we're just going to return false, right? So we can't actually apply it. If we loop through all the requirements and we do meet all of them, then we can now create the state that we want. So we can say f skill rank what do we call it? F character skill state. Skill state is equal to F character skill state. That. And we can say skill state dot current rank plus equals, I think we set it to 1. Yeah, so we actually don't need to do that. And this is, we need to do another check. I just realized something we need to do up here. We need to check, this isn't necessarily true. If it contains it, well, I'm thinking if it contains it, do we need to not unlock but rank up? So we need some sort of check maybe in here, potentially. Or that just means we're using the wrong function. Okay, so we're going to do this, and now we want to apply the effects, and we created the state, and now we want to apply the effects and add the handles to our new states class. So let's do, we now need the ability system component. I want to go to requirements and load up this. So we're gonna do a couple things. This is gonna be attached to our player character, our pawn. So what we should be able to do is do U ability system component ASC is going to be equal to our U ability blueprint library get ability system component, and we're going to pass in our owner of this actor component. If, again, we'll do another early return. If ASC is not good, it's failed. We'll grab this and we'll say fail to load to find valid ability system component on given owner actor component owner cannot unlock skill. I'm gonna put character skill here. I'm being pretty specific about these. Cannot unlock character skill. Because when you get further along in development, this might seem tedious or like not needed, but when you get further along in development and you start having tons of systems interacting with each other, you want to be able to trace back pretty quickly where things are happening. There's another optimization thing we can do here where we actually create a log category. So we're just adding this to the temporary log category, but we could actually create a log category that's specific to our character skill system. That might be a better route. Which I can, excuse me, I can show that in a little bit. So now that we have our ability system component, we actually want to apply those effects, and I'm going to show a subsystem I created, I think is in characters. Oh no, it's for gas. This gas service, which we might be able to leverage, where we initialize gas, where we have these things called grant abilities, where we pass in the abilities that we want to grant, and we apply attribute values. So I don't know, the only issue with this, and maybe that's just something I need to refactor, is that we don't return a list of handles or anything. So like we just grant abilities here where we pass in the gameplay abilities. And I think if I go to my service, They're all private as well. So not a big deal. What we can do is we're going to copy kind of what we're doing here. This is how we want to apply them. But what we want to do is actively probably create another function that leverages this in our service. But let's go ahead and first make it here, and then we can move it to our service. I think that'd be a better long-term plan because it's kind of not needed inside this component. This component should not manage how we grant and work with our ability system component. It's a little out of its zone. Zone? Not the right word, but work. Okay, so now that we have our ability system component, we want to loop through all of our effects. We're basically going to do this exact same thing over here. So for our effects, and let me write a to-do statement here. To-do, move to gas service class for better, we'll say for improved, no. All right, just a note for me, but we can do it here for now. So for each, we want to go into our character skill asset dot rank of interesting 0. It's really going to be of our skill state dot rank current rank -1. So I'll explain that in a second. And we want to do, this should be our skill ranks, and now we want to do the gameplay effects to apply, which is a T soft class pointer gameplay effect, which I think is what this ended up being. Yep, an array of them. Yep. All right. So now that we have each one, we want to check to see if it's valid. Do the same if statement here. I think honestly I can just do this. Let's type it out. Subclass of U gameplay effects. We're gonna load it synchronously. So effect class is equal to effect class pointer dot load synchronous. It's gonna load it immediately if the class is loaded. Yep, this is all should be the same. It makes sense. We're going to create a spec handle. And then apply it, the handle. And that's my ability system component. Doesn't look like it did the include. Okay. All right, so let's talk through this, what I did exactly, and a couple issues that we might see. So what we want to do is in our data asset, we had this skill ranks data. And if we go to that declaration, we can see that it contains an array of soft class pointers to the gameplay effects that we want to apply when we apply this skill. So we want to get access to that, and we're trying to do that here. We have this character skill asset. That's the loaded gameplay. That's a loaded asset. So that's this asset in Unreal Engine. It's fully loaded for us to use. And so now we're going to go to our skill ranks array, which is here. Skill ranks array. And the first rank of every spell, I'm going to make this more simple. We're going to set rank to 0 to match the index of our array. And all we need to do now is just say skill rank because it's 0. So we're getting the first index. So the first rank of our spell. So this is 0. And we're going to get the gameplay effects that we want to apply, which are soft class pointers, meaning that we need to load those pointers up. So a little confusing. And this specific case, if we remember, we're unlocking the skill for the first time. So if this is a rank up, this is different. In this case, this is a brand new skill that we're unlocking. And so we just need 0. We could just put 0 here, but we'll use current skill rank, which should be 0. Oh, I'm in the wrong one. I'm actually glad we checked that. It should be 0, not 1. Knowing 0 is the first index, first rank. So what we're doing is, again, we're going to loop through every soft class pointer. We're going to load if it's valid. If that pointer is valid, meaning it has a valid path, we're going to load it synchronously. We could optimize this and again load it async. If the class is loaded, we're going to create a effect context handle, and we're going to apply the gameplay effect to ourselves. And this is actually going to produce a handle that then we want to capture. And I realize it's called active gameplay effect handle. And if we go into our state, it's the wrong thing. So we want to say F active gameplay effect handle. And I wonder if this is F active gameplay. I don't think so. We'll do it for now. So the return that comes out of here is going to be a F active gameplay effect. Here. Like that. And then what we want to do is active, oh no, in our state. So state, where are we at? Our skill state dot active gameplay effect handles dot add handle. So for every gameplay effect that we want to apply, we're going to check to see if the pointer is valid. We're going to load the class. We're then going to apply it, and then we're going to add it to our active gameplay part of our skill state. That should handle it all. And now we want to do the exact same thing for our granting abilities. So we're going to copy this, going to paste it. And now instead of character, skill asset, skill ranks, gameplay effects to apply, we want gameplay abilities to grant. We're going to change it up just a little bit. We'll call this ability class pointer. If that pointer is valid, we want to load it. And this is going to be a subclass of U gameplay ability. And this is actually a UWK gameplay ability. This is our gameplay ability. Actually, and that does not matter. So we're just going to say U gameplay ability. And this is going to be an ability class. If it's valid, we're going to grant it. So let's go to our grant abilities. Here we go. If it's valid, we're going to make an ability spec. Honestly, we'll just go F gameplay ability spec. Perfect. And we'll call this ability spec. And what's going to take in the ability class and the rank, which is 1. And here, this is going to return a gameplay ability spec handle. That's what I thought. So we're going to remove this, paste that in there. And this is a F gameplay ability spec handle. And we're going to say active gameplay ability handles, add the handle. Perfect. Okay, so same thing. We're going to loop through. Let me just run through all this again. Maybe. Let me grab this same to do. So for our abilities, we're going to loop through rank 0 of all of our abilities to grant. We're going to get the ability class pointer. We're going to check to see if it's valid, meaning are we pointing to a valid path. We're then going to attempt to load the ability class. If the ability class loads, it's valid here. We're then going to create a new ability spec. Given that class in a rank 1, we're going to then give the ability to the ASC, which is the ability system component for this character. And then we're going to add the active handle to the state. Now, the last thing that we need to do is actually add it to our active skills. So we're going to say active skills, add, and we can say primary, what is it, skill asset ID, and then skill state. Yep. That's the last thing that we needed to do. And we'll return true. So if all this works out well, we're going to return true. Pretty cool. So a lot going on in here, really complex, but I think we can actually test this out in blueprints. So if it's blueprint callable, let's rebuild our project and test this out and see if it works. I think I should be able to test this out. I think it should work. Give it our improved wisdom. We'll have to verify. But we'll build it and see what happens. Nope. Undefined. So what I just did in my skill rank data, instead of using my custom implementation of it, where then throw some issues here, we're going to use the soft class pointer of gameplay ability, which my gameplay ability is just a implementation of it, so it still applies. So we should still be able to build. Give it a second and see. There we go. So we're gonna, in blueprints, hopefully add this component to our character. That's the plan. And we should get access to see our map, which should be empty, and then we're gonna try to call try unlock skill in blueprints. So if we go to content, we go to third person blueprints, our third person character. This is gonna look a little bit different than yours just because I've been playing around with some 2D stuff. I'm gonna add a character skills component. Perfect. There we go. If we come over here, we should see active character skills map. Right, we can't edit it, but it's still there. And what we can do is on begin play, we will get our component, and we're going to say unlock, try unlock skill. And you can see it takes in a skill asset ID, which we can pass it the skill that we want. So we'll do improved wisdom, and we'll do a print text, and let's do a format text, skill unlock say skill unlocked question mark, and we'll pass in the true or false value. Okay, so if we check out this skill before we test it out, I might change. Yeah, let's go to it. So if we go to our character skills, Let's look at improved wisdom. Improved wisdom is going to apply an effect. Add wisdom. And if we go to that, it's going to add 5%, I think, to our wisdom. Multiply, it's additive. The issue I'm thinking right now is that my character doesn't have any wisdom. So let me actually, oops. Let me press play. Let's test this out. So this is my character here. If I show debug ability system, we can see over here our wisdom. Oh, our wisdom is at 8. So theoretically, I think we have this set up to multiply by 5%. So if we do 8 times 1.05, that should be, I think, 8 times 1.05, 8.4. We might see 8.4 over here. So we'll test it out. Let's if it works. So let's go back to our blueprints. Let's connect it, and let's see if it tells us true or false. It says false, so it didn't unlock. So now we can see pawn is not valid. Cannot check gameplay tag skill requirement. Oh. We put the gameplay tag skill requirement on it, and we don't actually want that. Perfect. It was true. Skill was unlocked. And we can see our wisdom somewhere. Wisdom is at 40. Okay, so it multiplied 8 times 5. Yep. But you can see it actually applied this additive gameplay effect, add wisdom. That's the skill that we unlocked. So if I click my character, this is pretty cool. It's working. So if I click my character and I go to my character skills, in our active map, you can see that we have a gameplay tag. And we have a gameplay effect handle. So right now we have the improved wisdom active skill. This is the asset ID. It's at rank 0, which is our very first rank, and it applied the effect handles. You see here, we can't see it, but we know it applied the effect handle. We can see default gameplay effect add wisdom, and it multiplied 5 times our base, which was 8. So now if we go do our gameplay effect, that's not the exact thing we wanted. So let's do 0.05. I think that's more of what we want, 5%, right? Press play. We see skill unlock true at the top. We'll go to our debugger. And we can see wisdom is at 0.4. Oh, okay. I got it. We want it 1.05. I can't do math today, apparently. Try it again, and let's make the text a little bit more easy to read. Let's make it orangish color and last for 6 seconds. How about that? Compile, press play. All right, skill unlocked true. Perfect. If we go to our debugger, we can see we're at 8.4. So now we're applying 5% of wisdom to our base of 8, and it says it's additive gameplay effect add wisdom. So we have just applied our wisdom skill to our character. One thing that we can do, I was going to test, is I believe our level is 1. So we can test our requirements. If we go to our plus add and we say we want our level of our character to be level 1, it should still work. It said false. Let's check that. So now we know we have like a bug. And it looks like pawn is cannot check level skill requirement. So let's go look at that. Why that failed for a gameplay tag as well. So we know we have a bug in there. If we go to requirements, let's look at our I think I know the issue. And it's actually in where we apply the skill. Let's open up our base skill. And then let's open up our core component CPP file though. Okay. So what I'm thinking is happening is in our check here, we are sending in get instigator controller from our owner. And I have a feeling this is the problem. And we're just converting our pawn to a controller. And I don't think we need it. We need the pawn. So what I'm thinking that we do is inside this, instead of this, we're just going to pass in a pawn. And we'll just call it pawn, which changes all the implementation. But I think we don't need the controller, right? We're not using it for anything. So let's go to the pawn. It might fix some of our problems. For now, it might create some later down the line. I'm trying to think of when we need the controller. I can't think off the top of my head when we might need one. But we can pass in a owner. Oh. I wonder if... So pawn just assumes it's a controller. We just need the actor, which is going to be a character. I'm trying to think of how I want to do this. We might just do actor. Let's do actor for now. Character actor. We'll just call actor. I'm trying to think of these the issues of doing this. So if we say get owner and we get controller, so owner gives us our actor. We don't necessarily know this actor is a character. And what if we want... Yeah, we're gonna do get actor. And not a pawn. So I'm thinking through this. If we have an actor, that means we can apply it to anything, not necessarily something that's controlled by a controller or AI. It could just be an object in the world that has an ability system controller on it. I don't think that's necessarily bad. I'm sure I'm not thinking through all the repercussions of that. But for now, it should still work. The only thing that's going to change is some of our code in here. Where we're casting, which maybe that's okay. So what we can do, now we already have an actor. We can just pass in the actor and get rid of this whole pawn cast. So we'll say actor. Basically, does the attach actor have our have the thing that we want? I think it does. So we'll find out if I made a bigger problem here, but I think it will be okay. Perfect. Get owner. All right. Let's press play again and test this out. So if this works, we now have a requirement system works for all of our skills, and we've basically implemented this part, our data asset. We've implemented the skill state, and we've implemented part of our actor component where we can actually unlock a skill. The next thing we need to do is look at refunding and skill ups. And one thing we did not do is apply the cost of our component. So let me open up these assets just to test it out here. So we have the requirement on there of level 1. It should still say true. It does. We have a ton of errors though. Our health bar is broken. Okay. That's okay. All right, but our skills unlocked, that's true, and it's level 1. So now the next thing I want to do is set our skill unlock requirement to like level 5 and just see. It should fail. It's level 10. It'd say false. False. Perfect. Okay. So let's say at level 1, some testing. It works. True. Now we're going to add a new requirement. That's going to be our gameplay tag requirement. And we're going to say that our gameplay tags requires our character class to be a mage. So we're going to pass one of the requirements, our level, but then we're going to fail. So it should say false. Perfect. Now I think I have, if we go to, I thought I had made some classes. So I made some race. Yeah. So I think I can go in here and add the mage tag to our, I have a race, character race data asset for, I said mage, but just a race here. And I think if I apply the class, it should work. True. Yep. So what I'm doing, what I did is we added 2 requirements. Our character has to be level 1 and our character has to have this mage tag. And I added the mage tag through another data asset. If I get rid of it here, file, it says false because now we don't have that class tag. So our requirements array is working as intended. And we are applying our skill ranks, which is our add wisdom. We're adding 5%, which is our improved wisdom skill, through a gameplay effect. We could test out our ability just real fast. So skill ranks, we want to add an ability. So let's add the bite ability. If I press play, it says true. Should have done everything. We can see one of these pages, I think. Let me go to the next category. So you can see, going to the next page, we do have our wisdom applied of 5%. And you can see that we have the gameplay ability called bite. Super hard to read, but it's there. If I go back to our improved wisdom and I delete it, press play. It's no longer there. We just have our auto attack. So we have a completely data-driven way of applying skills, which is pretty cool. They have names, icons, that sort of stuff. And what we need to do next is we use active skills map. What we need to do next is ranking up and refunding and actually doing the cost part of our skills. So if we come into here, let's go into our not this one. I closed out of it. We want to go to our component. So one thing that we did not do is actually use the cost. Here we need a cost check. So I'm going to add this to our to-do list, and it's something that we'll work on in the next video. To-do, use, not use, what is it? Add skill cost. Add ability to apply skill cost. So one thing, before we unlock the skill, we need to go ahead and get our attribute that we have not created, which is our skill points. See if we have enough available skill points to then go ahead and subtract in order to apply the gameplay ability, or the skill, excuse me. But we're gonna leave it here for now. I've been going for about an hour and 15 minutes. We've been pretty successful. We've added, as part of our design, we have our fleshed out skill data asset. We've added our skill state, which monitors the active state of every skill that we have. And we created our skill component where we have our active skills map. And then we actually created and implemented the function to unlock a skill. And we've proven that out inside our editor, and we can actually see that our player has the skill improved wisdom on them with the intended gameplay effect. All using gas, all data driven, all scalable. This is how a studio would most likely implement some sort of skill system. So in the next video, we're going to continue on with the actor component and look at cost and adding more information. Talk to y'all next time.